Let us start our class now. Don't have any power, so I could not start. Now, in the last class, I have discussed the multiple stress, compound or multiple stress analysis. The basis of the difference between the multiple stress or compound stress and simple stress is that simple stress referred loadings are acting individually and independently over a certain prismatic path. But here, compound stress and strain is a phenomenon where multiple stresses which are acting all at a time on a certain prismatic bar of certain shape and size itself.
Your class was at 120 na?
Huh? Hello? कुछ बोला तुम?
Yes, sir.
क्या बोलছি শোন?
Your
Now-
class was at 120.
Yeah. क्या बोलছি শোন? अच्छा. Now, in this particular case of multiple stress system is that the different type of loadings are acting simultaneously or they are acting dependently to each other. So here we are assuming the loads are acting along the longitudinal axis, a load acting that is the longitudinal tensile or compressive stress and shear stress acting along the surface of the longitudinal axis itself. So both of them are acting together where their common effect of the over the bar is under our consideration. So far we have discussed the stress condition over a plane which is acting normal to the longitudinal axis of the system. Here we'll consider the stress situation of a plane which is acting at an angle with the normal plane, which is to the plane which is normal to the longitudinal axis. So what we have discussed here.
Hello.
Hello, follow. Now, first of all, in the last class, what we have discussed, a prismatic bar which is subject to a tensile stress sigma x along the longitudinal axis only. And what is the condition of the stress over a plane A, C, D, and F, which is acting at an angle which is placed or truncated the prismatic bar at an angle theta with the normal plane D, C, D, and E. And we have calculated the stress induced over the plane. We have decided, we have assumed that this the particular longitudinal bar has any unit thickness. It has thus length and thus width and 1 unit thickness, which means it's like a piece of paper. And if we take this portion of the bar ACB, it will take like a triangle, like as shown in the figure itself. So we are thinking that this triangle or this element of the bar is subjected to a tensile stress sigma x along x-axis, and we want to calculate. We have calculated the stress acting over the inclined plane AC, which is inclined with the normal by an angle theta, and the stress induced over the surface is sigma x, sigma theta, and tau theta. Sigma theta is the normal stress, tau theta is the shear stress, which is acting along the surface AC, and sigma theta is the normal stress acting normal to the surface AC. We have calculated both sigma theta and tau, and it becomes sigma theta is equal to sigma x cos square theta and tau theta become half minus half sigma x sine 2 theta, where sigma x is the longitudinal stress, which is tensile in nature, and theta is the angle of inclination of the plane ABC of the plane AC with the normal plane BC, it's BC. Now, the negative sign shows that tau theta, the angle which is shown here, like which is not in the either in the palm line, this angle which is created along, which is actually the anti-clockwise side. It is it is that it will be negative. So the tau theta is now counterclockwise and not clockwise as in the inline plane. When theta is 90 degrees, means there is no angle of inclination between this plane AC and AB, AC and BC. So in that case, sigma theta will become sigma x. If we put theta is equal to 0 here, cos square theta is equal to 1. So sigma theta will equal to sigma x. And if we put theta is equal to 0 here, sine theta will be 0, sine 0 degree will be equal to 0. So tau theta will be equal to 0. When theta is equal to 45 degree, or the included angle here is 45 degree, then tau theta is a sigma x by 2. Sigma theta is a sigma x by 2, because cos 45 degrees is 1 by square root of 2. So cos squared theta is equal to half. So sigma theta will be equal to sigma by x by 2. And tan theta will be similarly tan theta, which is, if we put the value of theta is equal to 45 degree or pi by 4, then this tan theta will become sine pi by 2, which is equal to 1. So that will be equal to minus sigma x by 2. So sigma theta is plus sigma x by 2, and tau theta is minus sigma x, and which is maximum and counterclockwise in orientation. When theta is equal to 90 degree, we put cos theta is equal to cos 90 degree, which is equal to 0. So tau sigma theta will be equal to sigma theta is equal to 0, which means so if this angle here is equal to 90 degree, when theta is equal to 90 degree, means this line AC will become parallel to the horizontal itself, like this. So it will become AC like AC, and there is no component of shear force at this line, which becomes 90 degree, then theta, sigma theta will be 90 degree. So if on this plane there is no vertical force like this, sigma theta, so this is equal to 0. And shear stress, which by putting the value of theta is equal to 90 degree, which means sigma theta is equal to sine 280 degree, that's also equal to, that is also equal to 0. That is so. So chi theta is also 0. So there is no shear stress acting on this particular plane, acting on this plane, which is equal to 90 degree, where theta is equal to 90 degree. Next, another problem comes when theta is equal to 145 degree, 135 degree. Means here cos square 135 is equal to 1 by square root of 2 whole square, sigma by 2. So sigma x divided by 2, and tau theta sigma x divided by 2 is the maximum, but clockwise in nature. So here the planes inclined at different angles need to be vertical along with the stress according to them. This means the following can be noted from the figures. A plane at an angle theta with the vertical also is the plane with an angle 180 degree plus theta. What is meant by this thing? Here, now, if this theta is equal to 45 degree, and what will be the theta is equal to 45 degree here, means this is at an angle 45 degree, and again if it is 90 degree, from this is 90 degree, this is 45 degree, and the angle will be 135 degree. What will be that? This is 45, this is 90, this is 100, again another 45. So this will be 135 from here. Now, so what we found here from this equation, the when theta is equal to 45 degree, the sigma theta is equal to 5 sigma x by 2. And when theta is equal to 35 degree, it becomes 10 sigma x by 2. And when at that moment tau theta is equal to minus sigma x by 2, which means the shear stress is maximum but counterclockwise, and tau theta is sigma x by 2 maximum but clockwise, which means that the plane at an angle theta with the particle also is the plane with an angle 180 degree plus theta. Thus, a plane at angle 45 degree clockwise will be particle can also be mentioned as the plane is equal to 140 degree clockwise or 135 degree counterclockwise. Similarly, a plane at minus 45 degree with the particle will also mean a plane of angle 45 degree counterclockwise or angle 225 degree counterclockwise or angle 135 degree clockwise. So what is meant by this program, these ideas? First of all, the plane which is acting another 180 degree away means we draw a line here. So this angle will be 45 plus 180 means 225. At the same time, this angle is in this direction, this angle is 135 degree. So in the clockwise direction, 225 degree, and anti-clockwise direction in 135 degree. This is anti-clockwise direction. So what it means that the plane at 45 degree clockwise is equal to the plane at 125 degree clockwise, at 135 degree anti-clockwise. All these three planes are same. 45 clockwise means 45 clockwise, 225 degree clockwise, and 135 degree anti-clockwise. So these are all what is said. These are all same. So they have the same value of sigma theta and tau theta, but their orientation may be opposite. Next, the normal stress to the inclined plane decreases with the angle theta. The normal stress in the plane decreases with the increasing angle theta from maximum to the vertical plane to the 0 to the horizontal plane. What you see here, normal stress sigma theta is maximum here, and then it becomes maximum half of them, then it becomes 0. Then what is this means? This is the maximum. This is become 0. So model phase with the increase in theta, with the increase in theta, will decrease in the value itself. What will happen to shear stress? Shear stress is negative counterclockwise between 0 to 90 degree and positive clockwise between 0 to minus 90 degree. So if theta is increasing from 0 to 90 degree, it is negative, and it increases from 0 to minus 90 degree, not exactly opposite direction, it has become positive. That a plane 135 degree vertical also means a plane at minus 45 degree. So what is this? Means a plane at 45 degree it can be, and a plane at 135 degree, which is equal to plane at minus 45 degree as described above. The maximum shear stress is equal to half of the applied stress. Now resultant stress, what will be the resultant stress on the plane ACDA? So here resultant stress sigma r, which is the resultant of sigma theta and tau theta, like this here, somewhere here, but may not be horizontal. Then sigma theta square plus tau theta square, which is equal to, if you put the respective value, it becomes sigma x outside the square root multiplied by cos square cos to the power 4 into cos square theta into cos square theta, or cos, you can bring out cos theta, that is equal to sigma x multiplied by cos theta into square root of cos square theta into sin square theta, which becomes sigma x cos theta. So the resultant stress is becomes the value of the normal horizontal stress multiplied by the cosine of the angle theta. Now inclination of the normal with the normal stress is tan phi sigma x sin theta by cos theta divided by sigma x cos square theta, means tau theta divided by tau theta by sigma theta, which means sigma theta sin theta cos theta divided by sigma x cos square theta, or tan theta, or tan phi will become, it is inclined with an angle equal to theta. So phi is equal to theta. The angle of inclination of resultant is equal to the angle of inclination of the plane with normal. So that is, it is always in the direction of the applied stress itself. Next, we are talking about, let us talk about biaxial stress. Means here only a single sigma stress along x-axis is not acting, but another single stress sigma y, which is vertical and acting on this angle AB, is also acting, which is shown here. Here sigma x was acting as well as sigma y is also acting. So dy and ds are the length of the side AB, BC, and AC respectively. So dx is the length of the side of this side, that is dx, and dy is the length of this side, that is dy, and ds is the length of this side, that is ds, and thickness is equal to 1 or unit. Now, if you resolve the forces in the direction of sigma theta, means in the direction here, if you resolve this force, the sigma theta ds will be minus sigma s dy into cos theta. If this is the angle, this is the vertical, and this is the angle of tangent, then sigma theta ds minus sigma x into dy into cos theta, or you can make like this. This is sigma x into dy into cos theta. Sigma x dy is here, the force acting over the hypotenuse, and sigma x cos theta is the component along this, along sigma theta, and tau tau theta or sigma y is acting vertically, means it is acting at this angle, which is if we take it as the hypotenuse, then it will become dx into sine theta, which is the vertical angle of it. This is the vertical height of it. So dx sigma y dx sine theta is equal to 0. Thus, sigma theta dx, sigma y dy into cos theta minus sigma y, sigma x dy cos theta, sigma x into dy cos theta, sigma y to dx into sine theta is equal to 0, 0. Sigma x dy cos theta and sigma x sigma y dx sine theta. So what we are doing is like this. Here we have to solve it in this way. Here what we are doing, the vertical angle, this is our C, theta, A and B. The stress induced is sigma y, sigma x. And this is the length dy, this is the length dx, and this is the length ts. And sigma, this is sigma is now what is sigma s multiplied by ds, the length of this side AC multiplied by the thickness 1 is equal to, or minus, which will be equal to, or if we add it, it will be minus sigma s, and this is the angle here. This is the hypotenuse, this is the vertical, and this is the horizontal line of this stress sigma x into dy. So its horizontal line, its horizontal component will be sigma x dy into cos theta, where this angle is equal to theta. At the same time, this is the vertical angle here, which is we are having sigma y into multiplied by the length dx. This is also, if we take a rectangular component of it, it will make a vertical rectangular triangle. Then this sigma is divided with the hypotenuse, and the vertical, this will be the angle. This is definitely, no, this is definitely vertical. No, sorry. This is comes in a different way. This is sigma y into 3x, as sigma y is the stress acting along the y-axis, and dx is the length of this area. Now, if we take make a vertical angle here, which is at an angle, theta, and then the sigma y this is vertical and this is hypotenuse. So the vertical of this rectangular triangle is given by sigma y into dx into sin theta. Sin theta is the angle between the vertical sigma y dx and the normal to base of this rectangular triangle. So this length is sigma y dx. So sigma is dx is opposite in direction, that is sigma x into sigma x into dy into cos theta. It is in opposite direction to sigma x, and again sigma y into dy, sigma y dx into sin theta. As we have to maintain equilibrium, this should be equal to 0. Now, if we divide them with like this, sigma x is equal to sigma x into dy by ds cos theta, sigma y into dx by ds sin theta, and dy by dx and dy by ds cos theta. But you can say like this, write like this, sigma x into dy cos theta, and what is dx? What is dx is given by this dx, this is dy by divided by cos theta minus sigma y into dx sin theta divided by ds. ds means this is the base. ds is equal to dx by sin theta, which becomes this dy is cancelling each other, this dx is cancelling each other. So this becomes sigma x sin square theta, sigma x cos square theta minus sigma y sin square theta. So that is the sigma x in terms of sigma x, sigma y. And we can put it in this particular line, sigma theta it is not sigma x actually. In the problem, it is not sigma theta. So this becomes sigma theta. To be better, sigma theta, and sigma theta will be sigma x 1 plus cos 2 theta divided by 2 minus sigma y 1 minus cos 2 theta divided by 2. We know what is 1 plus cos 2 theta divided by 2 equal to 1 plus 1 plus 1 plus 2 cos square theta divided by 2. So this will become 1 plus cos square theta, and this will become 1 minus cos 2 theta is equal to minus 1 minus 2 cos square theta, or we can write it like this. Not like this, but like this. One plus 1 minus 2 sine square theta divided by 2. This becomes 2 minus 2 sine square theta by 2, or 1 minus sine square theta divided by 2. So if we put this term together, it will become cos square theta minus sigma y sine square theta. So we can replace this thing like this, and we can further simplify it: sigma x plus sigma y by 2 divided plus sigma x minus sigma y divided by 2 into cos 2 theta. Now, if we drop the tau, or the shearing force which is acting in this direction, tau is become tau theta. So tau theta will become tau theta multiplied by ds, tau theta multiplied by ds plus sigma s into dy. Now this component which is acting in this direction, sigma x into dy on the vertical component of it, that is the sine theta. So sigma x dy into vertical component of this value is equal to sine theta plus, which is acting along this tau theta, and another line, and this vertical angle of this is sigma y minus sigma y into dx into cos theta, which is equal to 0. Again, if you put tau theta is equal to minus sigma x dy sine theta plus sigma y dx cos theta divided by ds and divided by ds. And if we put ds is equal to dy cos theta and dx sine theta, and we can put ds like this: minus sigma x dy sine theta divided by dy divided by cos theta plus sigma x dx cos theta divided by dx by sine theta. Means this is dx, this is dy, and this is dx. So for ds we can put, in order to eliminate the sine theta over here, dy over here,